Hey guys, welcome to 75 day LeetCode coding challenge, and today we are going to solve our next problem statement, number of provinces. So let's start. There are n cities, some of them are connected while some are not. If city A is connected directly with city B and city B is connected directly with city C, then city A is connected indirectly with city C. So if A is connected to B and B is connected to C, it means the city A and the city C is also connected. A province is a group of directly or indirectly connected cities and no other cities outside of the group. You are given n into n matrix is connected where is connected is equal to 1 if the ith city and the j city are directly connected, and is connected ij equal to 0 otherwise. Return the total number of provinces. So we have given an n into n matrix, and the city I and j is connected if the value of matrix is equal to 1. The ith is a row and j is a column. So if the if the matrix value at I row comma j column is equal to 1, it means the ith and the j city are connected. And if it is 0, it means it is not connected. We need to return the total number of provinces. So for this example, one is connected to 2, but 3 is not connected to 1 also, or 2. So 1 and 2 make one provinces because these cities are connected, but 3 is not connected to any of them. So there are two provinces. For this test case, no city is connected to each other. So the number of provinces is 3. 1, 2, and 3 are all are separate provinces. Let's discuss how we can solve this problem statement. So let's say we have this. These are the cities 1, 2, and 3, 4, and 5. So number of provinces is 3 because one province is this. These all cities are connected. These cities not. This city is one province. This is not connected to any other. So this is one province. This is second one, and this one is third one. So number of provinces is 3. 3 is the output. How we can solve it using a code? We can use graph DFS approach. So we can do DFS traversal for the graph. What is the meaning of DFS traversal? We can use a stack to travels through the graph, and we can use an visited boolean array. This is the boolean array to mark if the if the if any node is visited or not, right? Because in the graph there can be a cyclic dependency. So let's say this is the one node, and this is second node, and this is third node, and this is the cyclic. So we visit this node, then this node, then this node, and we can again visit this node. So unlike tree, graph can have a cycle, right? So if the graph have the cycle, we need some kind of boolean. So visited, we can mark it as a true. So it is visited, and if it is not visited, we can mark it as a false. And when we visit it, we can say it is visited, right? So it will ensure we only visit a node one time. What we can do for this, we start from a source source city, and we can do the DFS traversal. We can push, this is our stack, we can push the visited city in the stack 1, right? Now we can, so this city is visited, and we can say visited is equal to true, mark for this city. Then we can push the adjacent node in the stack. So remove the one as it is already visited, and push the 2, 3. So this is also visited, and mark it as a true and true, right? So these all three are visited, and now our stack is empty because there is no adjacent node of 2, 2, and 3, right? So we are doing it using a stack. We can use recursion. to recursively visit the node, and once we come out of the method, so suppose we are calling DFS method, then we again call the DFS, then we again call the DFS. Now as soon as the condition comes, there is no adjacent node, it comes out to the top. So then we know it has completed one province. So as soon as the method return while doing the recursion, we know ki the one province is completed, right? But these node are still unvisited, so it is marked as false. Then we can again do the DFS on this node and mark it as an true. And when the method return, we can say one more province is done. Then again same for this node also. When the method return, it say one province more is done. So we can keep on adding the provinces, and we can use the graph DFS approach to solve this problem statement. So yes, let's jump to the coding part. First we are saying we have the visited boolean array. So boolean visited new boolean. What is the number of city? It is the length of our matrix. So it will always be n into n. So our number of cities is n. So is connected dot length. Now we can count. Then now we can define uh, DFS method. DFS. We can take the is connected 2D matrix and the city that we are currently visiting and the our visited array. We are at the current city, we can say we are at the current city, so we can say we have visited the current city. So visited city is equal to true. Current city is visited. Now what we have to do? We need to, let's come to the diagram. What we have to do, if we visit the current city, we need to push the adjacent node attached to it. So let's do this part. This is the city that is adjacent to this city. So it is a 2D matrix, right? So we fetch the array of that particular city, which other city are connected. So the value can be 0 and 1. So 0 means that the I and j is not connected, and 1 means I and j is connected. So we can iterate over this array. Integer I equal to 0, I less than city dot length, I plus plus, and we can say if the current city is connected. And one more thing, in a 2D matrix, a city can be connect to itself also. So for this one, it have the value 110. So it is connected to the second city, but it is connected to itself also, right? And we are only visiting the unvisited city. So but we have already marked the current city that we are visiting as a true. So this condition we can also handle by saying only visit the unvisited city. We only need to visit the unvisited city, and we are already marking the current city as a visited. So this edge case is also handled. Now call your DFS method. What you are passing the is connected graph, and what is your next city? So this I is your city that is connected to your current city, and the visited array, right? So our DFS is done, right? Our DFS is done. Now what we have to do, we need to count the number of provinces. Now iterate over your cities. So I have said we call the DFS method on one node, and then it it will travel all the cities connected to it. So when we call it to add the one, two and three is all it visited doing the recursion approach. And when it comes out of the recursion, it means one province is completed. Similarly, we need to count the number of provinces. So we need to only call the DFS method that have the unvisited node. Let's say if the current city is not visited, if your current city is not visited, call your DFS. Call your DFS is connected city comma visited. Now the DFS is completed. We can say increase your number of provinces. One DFS completed means one province is done, and we keep on calling the DFS on the unvisited node. Now return your number of provinces. Let's make it more. Let's change the name so that it will be easy to understand. So provinces and provinces plus plus and return your provinces. Now let's run the test case. So we have some error. Let's check. Cannot find symbol city. City means I. Okay, so we have the same name, city and city I've used here. So let's call it cities. And I is the city. So, yeah. Error required but it found. What is the meaning of this? Yeah. So okay. So cities we also need to copy it here. So yeah, our test case is working. Now let's submit the solution. Yeah, so our solution is also working. Thanks for joining the session. Let's meet tomorrow.